So before you leave this activity, I wanted you to think back to way at the beginning of the school year when we were working on inverses. One of the things that I taught you to do is anytime you see or hear or read about the word inverse, I told you to think switch. Um, this is going to come up in the next few meetings, in the next few lessons, because we're going to learn that logs and exponentials are have an inverse relationship. And we're gonna talk about their inverse relationship graphically, like we do right here. We're gonna talk about their inverse relationship algebraically, like we address right here. Down here, we're talking about points and stuff and tables. Um, Exponentials and logs have inverse relationships that are affected in this aspect, and it's a good thing to be reminded of. So, like, for example, let's review this. I'm telling you here that you rewrite the problem with the y. So when they gave you this problem, it said f of x equals 2x minus 3. So I took the f of x out and I put the y in its place. Step number 2 says you switch the x and y. So here I rewrote it. Instead of saying y, I said x. And I said x is equal to 2. Instead of putting the x right here, I put the y minus 3. Then I started the next step number 3 says solve for y. So I started off by adding 3 to both sides of the equation. That caused those 3's to cancel out, and this became x plus 3. Then I went ahead and tried to get the y by itself by dividing both sides by 2. Those 2's canceled out. My y is left by itself. And for the last step, I rewrote it using function notation. This is function notation, or I'm sorry, inverse. This is the inverse. The way we use function notation to say inverse, we raise it to the -1 power. That's the symbol to say inverse right here. So the inverse function of f is x plus 3 divided by 2. And remember, the original equation up here was x times 2, and down here it's x divided by 2. We had 2x minus 3, and down here we have x plus 3, and then we're dividing by 2. So we ordered the operations that we did. Instead of saying minus 3, we said plus 3. We multiplied first up here, and then down here we divided last. So we changed the order in which we did them, and we changed the order of the operations. Here the points just switch. This is how this is writing about ordered pair points using ordered pair notation, and this down here is writing about points using function notation. So here what I'm saying, if you're on a function and your x value is a, then your y value is b. So this f of a equals b is the same thing as saying the point AB. So this saying the inverse, here I'm saying the inverse of that function is going to be b. If you put b into the inverse, you'll get out a. So what this is saying is that the point BA is on the inverse. And remember that line, that reflection, the y, it reflects over the y equals x line. This dotted black line right here is the y equals x line. Here's a function. I named it g of x. The blue function is g of x. The red function is the inverse of g of x. A point on g of x is the point 0, 2. So that means that a point on the inverse of g is going to be 2, 0. Same thing here. A point on the function is 1, 5. So a point on the inverse is going to be 5, 1. So just remember those things. The reason that I want you to remember those things is because there is an inverse relationship between exponential functions and log functions. You're going to learn more about log functions, the graphs of log functions, in the next lesson, but there is an inverse relationship. And we also consider the the algebra to be inversely related. So you just learn how to take a problem that's written in exponential form and to rewrite it into log form. You just learned this. So the exponent 2 raised to the x power is equal to 5. We can transform that, or convert it really. We can convert that to log base 2 of 5 is equal to x. And the reason that we do is because there's no way for us to get this x by itself in order to solve for x other than to change it into a log. So when the exponent is the variable, the way we solve it is to log it. Logs are the inverse operations of exponentials. So now the x is by itself. That means I should be able to go over here and type it into the calculator right here and get an answer. Here's the answer. So in other words, what this is saying is that if I take 2 and I raise it, now I'm rounding off because this number here is a decimal that goes on forever. But if I take the 2 and I raise it to 2.32 power, I'm going to get pretty close to an answer of 5. So just to be sure, let's see. What is 2 raised to the 2.32 power? It says it's 4.99, and if I keep adding numbers up there, now it says 4.999. So if I keep adding those numbers, what is it? 28. I need to get back up in the exponent. 2809489. There, it finally rounded over to 1. So there is a calculator showing you that that's the exponent that we need on a 2 to get the number 5 as an answer. But we don't want to have to guess and check. So what I need you to get from this video is the fact that exponentials and logs are both graphically inversely related and algebraically inversely related, and we're going to learn how to solve these exponents, because not all exponents can be changed to common bases. You've just finished learning that if I want to solve this equation, 2 to the x equals 16. Well, I know how to do that because I can rewrite this 16 as 2 to the 4th, and then I drop that and I solve it. Well, I can't rewrite that 5 as a base 2. So this one can't be rewritten. I can't rewrite it. So what do? I log it. And then you're going to learn that in the lessons to come. You're also going to learn about the graphs of logs. We're going to talk about domain and range, and we're going to talk about end behavior, and we're going to talk about asymptotes, and we're going to talk about transformations of logs and what they look like. And so all of that is yet to come.